Hi everyone, we are going to move on to the next topic, which is the k-nearest neighbor. This is probably the most basic, the most fundamental one in the world of machine learning. So let me give you an example. Say, well, if we have a x, y coordinates of many households, and the label of the dataset is whether this household has more than one car or not. So this is a binary classification. So we are just classifying whether a household has more than one car or not. And we are only using two features, the x and y coordinates of that household, nothing more. Okay, so how can we build this machine learning model? I have an idea. And this idea is based on the assumption that the people with the similar financial status, the similar age groups, will live together in the same community. Well, let me take myself as an example. I'm living in a community which is not that newly built. However, the sizes of the homes are quite similar in my community. Well, most of the homes are three-bedroom homes. Okay, three-bedroom homes, and you may find it is not really large for a big family with many kids. Well, it works mainly for young couples or some retired old couples. And so if I walk in my community, it's quite common that I can see some young kids and family walking their young kids, or I can also see some older couples. So in this case, well, I would assume that, well, the people in my community have the kind of the similar income and the kind of the similar number of the family members. So I can't imagine if a family has 4 or 5 kids and they are live in my community, and then I would say the houses in my community is not that big. So anyhow, this is my assumption. I'm assuming that if the people, if the household, if the homes are close to each other, and then I'm assuming that the resident in those homes are also having similar income status, the age group, and then the number of the family members. So if a household has several closest neighbors, they all have more than one car. What does that mean? That means the family I'm looking into, it's likely that that family also has more than one car. So probably the closest neighbors of that household are all working couples. Both the husband and wife have different jobs, so they have to drive to their work with two cars. That might be the reason they need more than one car. Or if I'm looking at another household, and this household is living in a community that there are so many retired couples. And for the retired couples, they are less likely to have more than one car. Probably one car should be sufficient. And then, if many closest neighbors they only have one car or they have no car at all, and then I can predict for the sample I'm looking into, it probably has no more than one car. So this is the concept of doing the k-nearest neighbor. So to do the k-nearest neighbor, there are three important things. So the first one is the k-value. How do we define the k-value? This is a hyperparameter we have to set before we create the k-nearest neighbor machine learning model. And how do we define the k? So intuitively, we want the k to be a smaller number, but not super small. So for example, if I do 5 nearest neighbor, and then for each of the sample I'm trying to predict, I'm trying to get the 5 nearest neighbor and then investigate their labels before I can predict the label for the new sample. The next one, neighbor. So how do we define the neighbor? The neighbor should be a sample which is fairly close to the sample I'm trying to predict. And then it brings up to the next point. How do we measure the distance? Well, there are quite a lot of ways to do that. And the very common way is to do Euclidean distance. So for example, if we have two samples, the first sample has x1, x2, x3, da 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 to xp. And then the second sample is u1, u2, u3, da 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 to up. And then if we want to get the Euclidean distance, and it can be calculated as this. And there are some cases that people say, no, that Euclidean distance could be wrong. So, for example, there's another one called Manhattan distance. And if you bring up the map of the Manhattan island, and you may find it makes sense. So, let me bring this up. So this is the Manhattan island. And if you want to zoom in a little bit and say if this is Trump Tower. So if I want to go from Trump Tower to here, Times Square, for example. So from Trump Tower to Times Square. Well, we can't really just draw a direct line from Trump Tower to the Times Square because we are going across a lot of the buildings and not all the buildings are going to allow you to walk across. So if you're walking, the best way you can go is you have to follow the streets, right? So you may have to go all the way down here, turn left, go here, and then make it down. So you have to follow the rows. In this way, Euclidean distance doesn't work, and you can do a Manhattan distance. So for the Manhattan distance, it should be the absolute value of the x1 minus u1 and plus the absolute value of x2 minus u2 and etc. So those are two of the most common distance matrices. And this is the illustration of the Manhattan distance and the Euclidean distance. And in scikit-learn, there are even more different types of the distance matrix available. And the first two, Euclidean distance and the Manhattan distance, we have already talked about that. And the next one, well, I want to talk about Minkowski. So for the Minkowski, well, this is another distance matrix, and we have to specify another parameter p. So that is another hyperparameter we want to specify. And the rule is, if we take the Euclidean distance, and then instead of doing x1 minus u1 and powers 2, we can do a higher degree. So for example, if we want to do Minkowski distance with the p-value, the degree as is 3, and then it will be changed to x1 minus u1 and powers 3 plus x2 minus u2 powers 3 again. And then, well, we are trying to, for this square root, and we are trying to get the root of the degree of 3 as well. So this will come to the Minkowski distance with the degree of 3. So here are some discussion. If we are doing the Minkowski and with the p-value as a 1, so it is a Minkowski, and then p-value is 1. So x minus y, and then this powers will be powers 1, and then for the root it will be 1 divided by p, which is 1 again. So if you are doing a Minkowski with the degree value as a 1, what is it? That is really the Manhattan distance. And if we do the Minkowski with the p-value as 2, so this p will be 2 and this p will be 2, and what is that? And that is Euclidean distance, right? So we can say for the Manhattan distance and the Euclidean distance, they are the degree 1 Minkowski distance or degree 2 Minkowski distance. Okay, and the next part, if you want to go to the official documentation of the k-nearest neighbor classifier, and this is what you will see. So that shows all the default values if you build up a k-nearest neighbor without specifying any hyperparameters. So by default, it will use the n neighbors as 5. So this means if you don't specify how many neighbors you are looking to, by default, well, scikit-learn will look 5 nearest neighbors. And what else? So the matrix, this is the distance matrix. So by default, it is a Minkowski distance. And then with the PS2. So PS2, and we are using the Minkowski distance. And what is that? So just now we have discussed, if we are doing the degree 2 Minkowski distance, that is Euclidean distance. So this means by default, if we don't specify any hyperparameter, a k-nearest neighbor you are going to get will use 5 as the k value, and then it will use Euclidean distance by default.